What is the ordered pairs? Let's see in the first relation, we have 1b, it's a ordered pair, of 5 comma a, ordered pair, of a comma b, ordered pair. So we have 3 ordered pairs. In relation 2, we have 1 comma b, 5 comma a, 5 comma c. So this is set notation. So in the set, we also have 3 members. And the first one is a function because 1, 5, 8 goes to different places. But the second one is not a function because we see 5 goes to A, 5 also goes to C. So that does not make a function. With numbers, the ordered pair is just points we know before. On the Cartesian plane, we have x-axis, we have y-axis. We have x value, we have y value. Right? The point, also ordered pair. But we use ordered pair, for non-members also. So ordered pairs. Let's see, we have this a set of ordered pairs, or this or set of points. We see each one is a point. So a domain can have multiple ranges, but a range can have multiple domains, right? So you mean a member in the domain. Okay, domain talks about all the members, right? So a member in the domain can have multiple ranges. No, cannot. It's the opposite. Let's go back. Let's see the difference of those two. So this two shows us the first one is a function. You see members in the domain. Members in the domain, they only go to one place. They cannot go to multiple places. They cannot go to multiple range. The second one, you see 5 goes to A, 5 goes to C, so that's not a function. Different members in the domain can go to the same member in the range. That's okay, like the first one. Just a member in the domain cannot go to 2 members in the range. All right. Well, let's see this example. We want to find the domain and the range, and maybe to check if this set is a function. All right, to see if this set is a function. Oh, okay. If any of you have a problem to log on, you can always go back to watch the video. All right. So this is domain. Domain is a set of the first member, right, in the ordered pairs. So we see -3, -2, -1, 0, 1, 2, 3, right? So we put all those members, the first members, in a set notation. That's the domain of this relation. The range is the second member in the ordered pair. 27, 8, 1, 0, 1, 8, 27. So we see this one is interesting. The first members are different. Right? First members are different. But the second members, we see 1, and the 1 is repeated. The 1 is repeated. And we see 8. 8 is repeated. That's okay. Okay. The second member in the ordered pairs can repeat, but not the first one. So this indeed is a function. It is a function. All right. Because, this is right on the reasons. because the first members in the ordered pairs are distinct. Okay, as long as the first members are distinct, are different, you know, the set is a function. Okay. Well, let's see a second example. The domain we have 9, 4, 1, 0, 1 again. Oh, you see 1, the first member repeats. If the first member repeats, we have to check the second one. Well, this one goes to -1. This one goes to 1. The second members are different, so no good. This is not a function. But in any case, we could talk about the domain. Domain just the values of the first members, right? So let's put over here domain. We have 9, 4, 1, 0, 4. Since 1 is there already, we don't have to repeat the second one. 4 and 9 is there already, right? So that's the domain. And range, -3, second member, -2, -1, 0, 1, 2, 3. Right? Range the second members in the ordered pairs. So this one is not a function. Okay, so it's not, it doesn't make, so this set doesn't make a function. Why? Because we have two ordered pairs, 1, -1, 1, 1. We see 1 goes to -1, then 1 goes to 1. So the one member in the domain goes to two places. The same thing for 9, -3. We also have these two, right? But the 1 is good enough to say it's not a function. Also, and 9, 3, right? Have the same first member, but the second member are different, right? So if the first member are the same, then we check the second member. If the second member are the same, that's fine. They're just the same ordered pairs, right? But if the first member is the same, then the second member are different, that fails to be a function. That's not a function. Well, let's see this example. So domain we have 2. Well, this is listed in order. With -3, -2, 0, then 2, then 4. Okay. And range we have -3, -1, 3, and 0, and 4. And 4. Then this -3, this -3 is repeated. We don't have to repeat in the set. But is this a function? No. Right? This is not a function. It's not a function. What's the problem? The problem is -3 corresponds to 4. -3 also corresponds to -4. So it's not a function. If we graph those points, right? If we graph those points, we see these 2 points on the same vertical line. Because when we have a graph, we can use something called a vertical line test. Right? On the vertical line, if the graph has 2 points or more points on the same vertical line, that fails to be a function. So we see these 2 points, right, on the same vertical line. So this is not a function. But this is a function, right? Oh, this is not, because these 2 points, -3, correspond to 2 points. So these 2 points on the same vertical line. So it fails to be a function. Anyone has any questions so far? Okay. Okay. So a function is a relation that assigns each element or each member or each value in its domain to exactly one element in the range. Right. So member in the domain can only be assigned to exactly one member in the range. So function can be represented in 5 different ways, right? It's like myself, can be represented in different ways. You know, in school, I'm a professor. At home, I could be a daughter, I could be a mom, right? Or somewhere else, you know, in the church, I can be a member, but it's still me. So similarly, you know, function can be represented in 5 ways. So it can be a statement, right? It can be a set of ordered pairs, we saw it. It can be a table of values. It can be algebraic equation, or can be a graph. Right? So let's see this one. This one includes a table value. You see this x and y. X is -2, -1, 0, 1, 2. Y has a value -3, -1, 1, 3, 5. We see the members of x are different, so that is a function. Or can be represented in this way, right? Or can be represented as a graph, or can be represented as an equation, or sometimes just one statement, right? So this one, how do we make a statement of this function? The statement we can make is f of x, or a function value is double the input, then add 1 to it, right? That would be by statement. And this one just graphs. And normally we use 2 or maybe 3. In the beginning, maybe we use table a lot. We use table values a lot. But gradually, we use algebraic equation and we learn their graphs. Right? So let's see this example, mapping students' names to their birthdays. Student name in the domain. I will have Maria, Armando, Cynthia, Kelly, and Rachel. And in the range of birthday, right? January 18, March 15, November 6, December 8. And Maria and Rachel have the same birthday. That's exactly fine. It's still a function. So what's important is each student can only have one birthday, right? Nobody has 2 birthdays. If someone has 2 birthdays, that's right. That doesn't happen in real life. So that's not a function. So a function is, you know, each person has one birthday, but different people could have the same birthday. Here we learn the linear equations, right? Linear equations are linear functions. Some equations are not functions, but linear equations, all linear equations makes linear functions. So we have y equals to 2x plus 3. Remember there's a slope-intercept form, right? Now if we change y, we call y f of x. So make this function. So we read this notation as f of x. Okay, and we call it function value. Function value. So this we don't call y anymore, we call function value. Right? F of x equals 2x plus 3. So you see f of x is a function in terms of x. X is a variable. 2 is a scalar, 3 is a constant. So what is the domain of this function? Right, which means what can x value be? It can be any real number. It can be any real number. Right? So that means usually we use the interval notation to represent any real number. All real number means goes from negative infinity up to positive infinity. So this we call interval notation. Right? So this represents, in words we see all real numbers. In interval notation we see open parentheses, negative infinity, comma, positive infinity, close parentheses. In set notation we said, any numbers square is non-negative. Right? Any number multiplied by itself is non-negative. Over range similarly, all real numbers, right? So that's what's nice about the linear functions. But when we draw this graph, what's this graph? The graph is a straight line, goes on forever, right? So because our Cartesian coordinates is small, so it only capture part of the, the line. Line goes to two ends infinitely. So that's why its domains are real numbers, its ranges are real numbers. Anyone has any questions? Last class we talked about real numbers, right? The real number line, 0 sits in the middle. To the right, all positive numbers. To the left, all negative numbers. That's it, right? We have this real number line. Well, here we only have integers, but we could have fractions, could have irrational numbers also. And we call 0 the origin, right? To the right, positive numbers. To the left, negative numbers. Ajeda, any questions?
Yes, Professor, can you hear me?
Yeah, I can hear you.
Okay, thank you. So just to clarify, real numbers don't include things like fractions or decimals, correct?
No, real numbers is this. Any number multiplied by itself is not negative. Real numbers versus imaginary numbers. Imaginary numbers we'll learn in the future is when you square it, you get -1. Like a square root of 2, pi, all real numbers.
Understood. Thank you.
Okay. Fractions are real numbers. Decimals are real numbers. So is any value in the domain mapped to more than one value in the range? No, right? Otherwise, it's not a function, right? So it's a relation, yes. It's a function, yes. Because no x value gives two different f of x function values, right? If we evaluate f of 1, that equals 5. If we evaluate f of 2, that would be something else. So it is a function. So linear equations are linear functions. So remember we used to talk about x equals a value, y equals a value. But now in two-dimensional world, we have x-axis, we have y-axis, we have Cartesian coordinates, right? And y equals 5, we can write as f of x equals 5. When we draw the graph, it's a horizontal line. So it's a constant function. It's a constant function. It's a graph, it's a horizontal line. Let me see if I have a graph. I don't really have a graph. The graph is a horizontal line. Okay, I don't have Cartesian. Okay, let me find one. So usually I go to, usually I just Google it. So let's see, F graph. Perfect. Copy image. Okay, so this is a graph of y equals to 2x plus 1, or f of x. It's for this one. F of x equals to x. Oh, this is plus 3. Actually, let me change this to be 1. Change to be 1. Right? So this is a graph. We see 1 comma 3 is here, right? Because this one plug in 1. So x equals 1. Usually we just use 1 instead of x. Right? X can be any value. If we assign x to be 1, we just write f of 1. So this means 1 comma 3, right? The point is 1 comma 3. So that's this one. That's this point. You can check 0 comma 1 is on the line, 2 comma 5, 3 comma 7, right? So that's this graph. And then y equals to 5. Let me get y equals to 5. I may not able to get y equals to 5. Let me see if I can get it in. I'll change to negative 3. Okay, y equals to 5. Well, y equals to any number. I just need a graph of a horizontal line. Got it. Okay, I have here. This is a C. So graph looks like this. Okay, so horizontal line. But instead of C, that would be 5. Oh, actually, you know what? Let me use this. So on this graph, that's 1.5. Let me change this one to be 1.5. Or 3 halves. Okay. We see this one is 3 halves. Right? So we can write this as a function. So we'll call this constant function. Right? 3 halves, constant function. The graph is a horizontal line. What is its domain? The domain is all your numbers. What is its range? It's only 5. Okay. You see, constant function is not all your numbers. I gotta change this. Only 3 halves. Because constant function is only one value. Doesn't have x. Doesn't depend on x. Different from this one. This one, what's its domain? All your numbers. What's its range? All your numbers. But for this one, domains are real numbers, but the range only has one value. So this is a function. All right, this is a function. So the horizontal line is a function. Now let's say x equals negative 3. This is a vertical line. A vertical line, this green color. This is not a function, right? It fails the vertical line test. So before, when we see x equals to negative 3, we think about one dimension, but now we're in two-dimension world. So we represent this green line as x equals to negative 3. All right, so in two-dimension world, and it's not a function. What is its domain? Only negative 3, right? So only one number is in its domain, only one x value. You see all the points on this green line has x value -3. So only one member -3 in the domain. What is its range? Range is all real numbers. Because this green color line go up forever, go down forever. It covers all real numbers. So what's x-axis? X-axis is a real number line. What's y-axis? Y-axis is also a real number line. Anyone has any questions? Okay, so all lines, all straight lines are linear functions except x equals to a number, okay, except the vertical lines. But now let's see this one. So we read the number line from left to right and down to up. Okay, let's okay, the two, okay, we see x-axis and the y-axis intersect at the origin. Remember, real number line has 0 in the middle, right? If it's horizontally to the right, positive, to the left, negative. If vertically to the up, positive, to the down below x-axis are negative. So those two real number lines intersect at the origin 0. So the origin now becomes 0, 0. All right, we always read from the origin, from 0. 0 to the left, positive, 0 to the left, negative, 0 to the up, positive, 0 down, negative. Does that make sense? Does that answer your question? Okay, we don't read from left to right or up and down or down up. We read from the origin. We'll talk more about this, okay, if this is confusing. So would it better if you put infinity? Oh, I see. Your question is about the infinity and negative infinity. You know, mathematics have a lot of things just by convention. But just people used to do that. Yeah, people used to do that. And when we talk about real number line, we start from negative infinity up to positive infinity. And you're right, from left to right. And then we talk about the y-axis from down to up. In that sense, you are right. When we talk about all real numbers, it's just by convention. But if you see, there's nothing wrong if you put from positive infinity to negative infinity, right? It's still real number line. But just by convention. Just by convention, you know, we agree, we write negative infinity up to positive infinity. All right. Now let's see these two examples. You're welcome. You're welcome. Always ask questions. Great questions. I like questions. Let's see now. This again is by convention. Okay, by convention, we see y equals x squared is a function, right? Because we change y to be f of x. We change y to be f of x. So we see this is a function of y in terms of x. And then the domain is from negative infinity to positive infinity, which is all real numbers. The range, because it is a square. So what can the function value be? What can y be in this case? The smallest value is 0, right? Because 0 squared would be 0. Our negative number squared is still positive. So range goes from 0 up to positive infinity. Right? So this is a function. This is by convention. Then you may say, oh, what's wrong with this? Why can I make this function? It's not a function of y in terms of x. Okay, in terms of x. Why? Because if x equals to 4, then we see y can be 2 and negative 2. We get 2 ordered pairs. We get 4 comma 2, 4 comma negative 2. Right? So one x value corresponding to 2 different y values. Right? You may say, okay, if this is not a function y in terms of x, but it is a function of x in terms of y. All right. If you call the horizontal axis a y-axis, you call the vertical axis x-axis, right? Then this would be a function, right? But just by convention, we make the horizontal axis x-axis. We make the vertical axis y-axis. Just by convention. The horizontal one we call x-axis. The vertical one we call y-axis. But in the future, when you learn pre-calculus, when you go into pre-calculus course, you know, when you go to a higher mathematical course, we do talk about, okay, this is not a function of y in terms of x, but it's a function of x in terms of y. All right, that's for future. But for now, for this course, this is not a function. All right, why? Because one x value corresponds to 2 different y values. Any questions? Okay. All right. Let's see this one. Remember the 2 long bar represents absolute value, right? This is saying y equals the absolute value of x. If x is a negative, then absolute value changes it to be positive. So what is its domain? Its domains can be all real numbers. What is its range? Its range is from 0 up. We use bracket because 0 is in the range. Right? X can be 0. 0 absolute value of 0 is 0. The absolute value of negative values become positive values. So the range is positive number and 0. So this is a relation, and this is a function, and it's called an absolute value function. And again, because each value of x only outputs one function value, or corresponding to one function value. And if I like, let me copy a graph here. Absolute, because the graph is so important. All right, copy image and paste. So convenient in Google. So this is the graph of absolute value of x. All right. This is we have 0, 0, right? Because 0, absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of negative 1 is positive 1. Negative 2 is positive 2. So we have this symmetric graph, 2 lines. Okay, if we are given a function, we can evaluate the function, and we call the function value. Let's see this one. So this is a linear function. Reflection. Oh, you could call it reflection. You call reflection over y-axis, right? So usually this is called symmetric. It's a symmetric over y-axis because with functions we talk, right? You could call it reflection. Reflection over y-axis, that's fine. Okay, so with function f of x, right? We have these ordered pairs, right? X comma f of x is an ordered pair. And x is an independent variable. That means we can assign x any value if the value is in the domain. And the function value is a dependent variable because its value depends on the value of x. Let's see this function. We have f of x equals to 2x minus 5. And if this equation, when x equals 1, we can find the corresponding y value, right? So similarly to the function, we have f of x equals to 2x minus 5 is a function. And how do we find the function value? When x equals 1. So how do we write? We write it like this. We write it, okay, maybe I keep y here. Equals the f of 1. So we change, so when x equals 1, we change the x in the parentheses, becomes 1. So f of 1, okay. That means f of x equals 1. By convention, we write this way. So we write f of 1, so now x is 1, input is 1. So 2 times the input minus 5 equals negative 3. Right, so that gives us a point. Right? That gives us, so x equals 1, f of 1 equals negative 3. That's an ordered pair or a point, 1 comma negative 3. Right. We can evaluate f of x equals 3. We would call f of 3. Do 2 times 3 minus 5, we get a 1. So we get another ordered pair or point, 3 comma 1. We can assign x to be negative 1. Then we plug in, so 2 times negative 1 minus 5, that's negative 7. Then we get another ordered pair or another point. So this is the evaluation of a function, very similar to evaluation of an equation. So given a function with algebraic expressions, we can translate into a statement. We see multiply the input by 3, multiply the input by 3, then subtract 2 from it, right? Then subtract 2 from it. So we want to evaluate f of a, f of 2x, f of x minus 1, f of x plus f of 1, f of k squared. So we see the input are different, right? But we will follow the pattern. We will follow this pattern. So it really depends on the input, right? Let me make this, mark this. Depends on input. Now the input is 8. So we just change x to be 8, right? So 3a minus 2, and that's it. Well, f of 2x, we change x to be 2x. We still follow 3 multiplied by the input minus 2. So that's 6x minus 2. F of x minus 1. Now the input is x minus 1, but we will do the same thing. We multiply 3 with the input, we subtract 2. We simplify this, we get 3x minus 5. Or we can add two function values, right? F of x equals 3x minus 2. F of 1 equals 3 times 1 minus 2. We simplify this, we get 3x minus 1. F of k squared. Now the input is k squared, but we still follow the pattern. So we get 3 multiplied by k squared minus 2. So this is called evaluation. Okay, you see, sometimes we get the value, sometimes we don't. It's fine, right? In this case, actually, we don't get any specific values. But if we do assign x a specific value, and we should get a specific value for the function. Let's see this example. So we have f of x defined as 2x minus 5. So in a statement, this is saying multiply the input by 2, then subtract 5 from it. Right? So the input is x plus 1 now, which is multiply the input by 2, subtract 5 from it. Then we simplify distribution, right? 2 times x plus 2 times 1, then minus 5. So we get 2x minus 3. F of a, this is 2a minus 5. Well, f of 2, well, 2 is a number. If 2 is a number, we evaluate, get the function to be a number also. Function value is a number. In this case, we get a one ordered pair or 1 point, on the graph, right? If it's evaluation for s, what is equal to s minus 5? Just change the variable from x to s. F of s plus 1. Now the input is s plus 1. Follow the same pattern. We multiply 2, the input, and subtract 5 from it. Then we simplify, get 2s minus 3. We could do f of s plus f of s plus 1, where f of s is this, 2s minus 5. F of s plus 1 is 2s minus 3. So we could add those two. 2s add 2s is 4s. Negative 5 minus 3, that's negative 8. We can evaluate f of b squared. This input, you can put anything you want. That's 2b squared minus 5. You can input 3x, 2 times 3x minus 5, 6x minus 5. F of 3x plus 2, your input. So we'll still do the same pattern. We'll do 2 times the input, subtract 5. Then we simplify. Anyone has any questions? Okay, so this is called evaluation, right? So every function is like a machine. We just follow the machine, to change the input to be output. Okay, quadratic functions. We talk about linear functions, y equals x plus b. Quadratic function has this, f of x equals ax squared plus bx plus c form. And a will not be 0. Because what happens if a is 0? If a is 0, 0 times x squared would be 0. That becomes a linear function, right? Bx plus c looks like mx plus b. That becomes a linear function. So given us this quadratic function, let's see, we can evaluate f of 0. That means we just change x to be 0. 0 squared is 0. 0 times anything would be 0. So left with 7. 0, 7 is the y-intercept, right? Because x value equals 0. Let's see that we can evaluate at negative 2, right? We just do 2 times negative 2 squared minus 3 times negative 2 plus 7. Then we simplify, we get 21. Okay. So we get negative 2. Hold on. Why this is 7? So negative 2 squared, that's positive 4. 2 times 4, that's 8. This is right. Negative 3 times negative 2, that's positive 6. So 8 plus 6, 14. 14 plus 7, 21. That's right. So this is not right. Okay. So negative 2, 21 is a point on this quadratic. And maybe some of you know already. So the graph of this quadratic is upward parabola. So negative 2, 21 will be 1 point on the upward parabola, right? Same thing for 0.7. Will be 1 point on the graph. But f of a is still something unknown, right? Just change the function of x into function of a. It's still 2a squared minus 3a plus 7. Okay, if anyone has any question, feel free to stop me at any time. Right, we can find f of b, right? Just do 2b squared minus 3b plus 7, basically change x to be b. We could do f of 2b, change x to be 2b, now 2 times 2b squared minus 3 times 2b plus 7. Or simplify this, 2b squared, that's 4b squared, right, without parentheses. 4 times 2, that's 8. So we got ab squared. Then minus 3 times 2b, that's negative 6b. Well, plus 7 just still plus 7. Well, this one input is 2b plus 1. We'll follow the same pattern. We'll do 2 times 2b plus 1 squared minus 3 times 2b plus 1 and plus 7. Perfect squares, right? Perfect squares. Perfect squares means square the first one. So parentheses 2b squared is 4b squared. Then 2b times 1 is 2b, double it, 4b. Then plus 1 squared is just 1. Then we find like terms to simplify. So in the end, we have ab squared plus 2b plus 6. So that's the evaluation for the input 2b plus 1. Right? You need to remember this formula, okay? It's called perfect square formula. When you expand, you get the first one squared plus the second one squared plus the product of those two, double it, right? You could check the multiplication. You FOIL a plus b times a plus b. This is FOIL it. And in the end, you get a squared plus 2ab plus b squared. You can make sure you try to remember this formula. Okay, this formula is so important when you go to pre-calculus class. Let's see this example. We have this quadratic function, upward parabola again, right? We want to evaluate f of x plus 1. Again, we just change x to be x plus 1, okay? X to be x plus 1. Then simplify. In the end, you get 4x squared plus 5x plus 2, right? Another quadratic function. Or we could subtract two functions, right? F of x is 4x squared minus 3x plus 1. Subtract f of x plus 1, which is subtract 4x squared plus 5 plus 2. Right? We can do 4x squared minus 4x squared, that becomes 0. Negative 3x minus 5x, that's negative 8x. Then 1 minus 2, that becomes negative 1. Okay, let's see how do we use the idea of function in life. So this example is saying the daily cost to the printing company to print a book is modeled by this function, right? Modeled by this function. What kind of function is this? Linear function. What is its slope? Its slope is 3.25. Book, how many books is being printed? X many, right? X many. So X is the number of books printed. So let's say A, B, C, D. A, we want to determine the independent and dependent variable. So that's easy. X is the independent variable. C of X, right? Instead of calling f of X, we call C of X, cost function. Cost of making X many books, right? And then now ordered pair is X comma C of X. B, find the C of 0. Well, that's easy. Just plug in 0 for X, right? C of 0, well, 2.5 times 0 will be 0. This is 1500. So this is the overhead, right, of printing any book. So the cost of printing no book is 1500. I usually call this business overhead. Maybe you have to rent a place, you buy the machine, stuff like that. That's overhead. C, find the C of 1000. What is change X to be 1000 books being printed, right? So that's 3.25 times 1000 plus 1500. So that's 4750. So if the shop print 1000 books, that would cost them 4050. D, interpret what the slope represents in this particular context. The slope is 3.25, right? Remember, what does X represent? X represents how many books? If X equals 1, this is 1 book costs 3.25. If it's 2 books, 2 times 3.25, right? So that means each book printed, the printing cost of each book is 3.25, right? So it represents the ratio or rate of change of the cost and the number of books being printed, right? So, or each book printed printing each book. So each book printed will be 3.25, right? Any questions for this? Okay, let's keep moving. Let's see this example. The number of unwatched shows in Sylvia's DVR is 85. So this number grows by 20 unwatched shows per week. So each week she gets 20 more new shows. The function n of t equals to 20t plus 85 represents the relation between the number of unwatched shows n, so it's how many unwatched shows, and the time t. So t represents the time measured in weeks. Okay. So this is this one per week. So each week she gets 20 more. Each week she gets 20 more. So 20 is the slope, right? So 20 is the slope. So 20 times the number of weeks and plus she already has 85 unwatched. So A, determine the independent and the dependent variable. Or the independent is t, right? Dependent is n of t. Independent means, you can assign any value to it. But the n of t depends on the value of t. Okay, let's find n4. Well, just change t time to be 4 weeks. So n of 4 would be 20 times 4 weeks plus 85. That would be 165 unwatched shows. Interpret what the slope represents in the context. Right? So each week, right? That's right here. Each week she gets, she gets 20 more unwatched shows. Any questions? Okay, so 3.6, next section talking about the graph. Okay, it's so important. It's very, very important for you to, so in your brain to make the correspondence of algebraic expression of functions and the graph of that particular function, all right? It's like a, linear function, straight lines, right? And we have what if we have f of x equals the number that's in the horizontal lines. If we have x equals a number in the two-dimensional world, it's a vertical lines. And to determine if a graph is a function or not, we use a vertical line test. Let's say we have those 6 graphs. So the first one is a function. Why? Because anywhere, put a vertical line, it only crosses the graph once. A circle is not a function. Why? Because if we put a vertical line somewhere, we see it cross 2 points. So a circle is 2 functions. A circle can be made into 2 functions, but it's not one function. And this one actually is 1 over x. The first one is absolute value of x. This one is 1 over x, rational functions. Anywhere we put vertical lines, only cross once. But we have 2 branches. We have one in the first quadrant, or one in the third quadrant. So that's 1 over x graph. Well, let's see this one. This is like a sleeping upward parabola, right? It's not a function, right? Because this, we see this vertical line goes through 2 points. And this one is a function, right? It passes the vertical line test. And this one also a function. We call this a step function. The last one, step function. It's also a function because it passes vertical line test. Any questions? Okay, so this is called a vertical line test if we are given a graph to decide if the graph makes a function. Okay, so we want to be able to, to identify some basic functions. Oh, let's see this one. So we have a graph, the dark blue color, right? So that is a function, that represents a function. So we see, it passes a vertical line test. Now we can ask 2 questions. What is the domain of this function? Domain, we read the x-axis, and we read from left to right, as before someone reminded us. The domain we read from left to right on x-axis, right? So we see on the left is -3, but with open parentheses, because there's an open circle there. That means -3 itself is not in the domain. And then we read to the right, we see 1, up to 1. 1 is in the domain. So we use a bracket to represent. So the domain is from -3, but not including -3, up to 1, including 1. Interval notation. Domain talk about the x value, x-axis. Now we can check range. Range we read vertically. We read from down to up. We're starting from down, going up. Well, down we see starting from -4, go up to 0. So both included. So we have bracket of -4, comma 0, and close bracket. So that's the range of this function. Or table values, let's see we have this set of ordered pairs, right? Domain, sometimes we use x, then long bar, x equals to represent a set, right? It says, okay, x belongs to any of those numbers. The y, range is y can be any of these numbers. Then what does x, vertical bar x mean? So we can list in the table x, y, 0, 0, 1, 1, 2, 4, so on and so forth. So this is the table values. So this is a set, right? A set of ordered pairs. And indeed, this is a function because the first members are distinct. But table value, this represents a function. Why? Because x value are distinct. Well, this kind of table, x value, check x values are distinct. is a function. X values distinct is a function. X values are distinct is a function, represents a function. Well, let's see this one. Constant function, the first one, right? Constant function. Linear function, a straight line. Absolute value function. This is called a step function, all right? Or greatest integer, or called ceiling function. You see, look at the steps, right? Usually people call step function. Quadratic function, cubic function, square root of x, cubic root of x, a to the x, and with a positive. With a negative, we go through from the second quadrant to the first quadrant. Log function, right? Log base a of x. Log function. Rational function 1 over x. So this is rational function, another rational function. So 1 over x, this is a more complicated one. Trigonometry function, sine x, cosine x, tangent x, cotangent x, so on and so forth. But we're going to talk more about those functions, each functions, all right? Anyone has any questions? "32 students, all right? So I'm missing 32 of us. That means 31 students. We're missing 9, we're missing 10. Let's see which 10 I'm missing. Online class, okay. But they can always watch the video later. Anyone has any questions? If you don't have questions, you feel good about this material, go ahead, log out, go to my open math to do your homework. Okay, I'm going